Hi, everybody. Welcome again to KernelCon, and welcome for the first time. If you slept in and missed the keynote this morning, shame on you. So we're here to kick off the Terrified Chipmunk track, so hopefully you're in the right place. I'm here to just introduce Nader quickly, and I did have two quick announcements. One, I wanted to remind everybody, I'm not sure how clear it was at registration, the lanyards, the black ones are the standard lanyard. The yellow ones are the special, please don't take pictures of me lanyards. So it's totally your preference. But if you're wearing a yellow lanyard, people should be adjusting their angles in their pictures to not include you, which just makes it more difficult for them to take pictures when they're out in the villages and stuff. So if you really don't have a preference or don't care, the black ones make it easier on others. If you truly did not want pictures taken of you, please keep the yellow ones on. If you signed up for the Diversity, Equity, and Inclusion, the DEI luncheon, please see Wacy. He has the Technicolor lab coat, the spray painted multicolored one, or Dan, who is very easy to spot. He looks like a crazy scientist or a bag of popcorn, depending on the time of day, or myself, and we can direct you to the right place if they didn't give you that information at Reg. So with that, I'd like to invite Nader up. Nader is obviously with Mandiant, part of Google now, and it's a pretty interesting talk. I run part of the CFP for here, and it's a pretty interesting talk because he's got experience from both the investigation and the remediation side, like years and years of experience on kind of both ends of that. And what you're talking about today, if I remember, is not specific to AWS and cloud, but as sort of like an exemplar of one of the largest cloud providers. It's great to sort of exercise what you've discovered in the real world there. So I think it'll be an interesting talk, and with that, I will give it up to Nader. Thanks. Cheers. Oh, and this is your speaker.
Hello, hello. Can you guys hear me? Testing, testing. All right. Thank you for that intro. My name is Nader Zaveri. I'm a senior manager with Mandiant, now part of Google. Before we begin, show of hands, who in here is part of an organization or enterprise that's in the cloud right now? Awesome. Keep those hands up if your organization still they're in AWS. All right, so this specific talk is going to focus a little bit more heavier on AWS, but as was mentioned before, it's not specific to AWS or in terms of the metadata service. So with that being said, there's a good chance 90 to 95% of you guys could be affected by something that I'm going to be talking about today. But do not fret, we're going to explain what this is, how is it being abused, and how you can remediate, prevent it from ever happening. All right, so just to kind of go through a quick little agenda item. So first things first, I'm gonna do a quick intro of myself, kind of what we do here in Mandiant, and then a kind of overview of the cloud metadata service. And what that is, why do we care? Why am I here? This is a big thing, like why are you here, Nader? And then we're gonna go through the threat landscape. What are we seeing right now in terms of how threat actors are trying to abuse this metadata service? This is not something new, but something kind of novel is the way we saw the abuse, the rampant abuse of it. And then we're gonna go through like a quick little timeline of a specific type of attack where we had the threat actor go against this specific misconfiguration around some metadata service, and really around some threat intel on what we're seeing, so that way you can go back to your leaders and start to go through your environments. And I'll be giving specifics on how you can take this and go to today or tomorrow and start to review your environment. And what I'm going to do is I'm going to go through a demo technique of how this threat actor, we're calling it UNC2903. This is just a Mandiant categorization if it's not related to a specific APT group, Advanced Persistent Threat Group. We like to categorize them and cluster them into UNCs. And after we cluster a few UNCs together, we then, if we have similar TTPs, we then graduate them later on. It's a year-long, years process. If you ever had a chance to read any of the Mandiant APT reports, you see that we track people for 10, 15 years before we can categorize them into a specific APT group. And then at the end, I will go really heavy and deep around the detecting of this specific abuse, how to remediate, how to discover it in your environment, and then last but not least, how to prevent this from ever happening, because that's what we really want to care about. We don't want to always fight fires all the time. A little bit of housekeeping items. The case studies, the clients I will be kind of talking about, I'll sprinkle it throughout my conversation. It is not related to one or two specific incidents. This is dozens of incidents that we've had that we kind of put it together to kind of obfuscate a little bit so those clients do not get called out, especially if it's not a public incident. Quick introduction about myself. As I mentioned, I'm a senior manager with Mandiant as part of the incident response and remediation team. So what that means is during an IR, I'm part of the IR team as well, but really I'm focused on containing and remediating the holes the attacker has been able to utilize to exploit the environment. Another function of my kind of day-to-day is doing proactive type of engagements, which is around cloud assessments, cloud engagements, where I'm looking at different types of cloud environments, not just AWS, GCP, Azure, across the different cloud platforms. And been doing this for about 15 years, pretty heavy on Twitter, LinkedIn. I'm an open door policy, so if you ever have any questions for me that you don't want to ask right here, please feel free to ask me on there. And I've seen this happen one time in a talk, and I liked it a lot. So I'm part of Mandiant, we're part of Google. We are always hiring. I am willing to hire talent anywhere. I'm hiring on my team. So if you are interested in a new job or you're looking for a job right now, feel free. I have my business cards here. I am here always to assist in trying to find, maybe not, it won't be for my team, maybe it's a part of another person within my umbrella. So now kind of starting off with the cool things, which is what is metadata service and what is really the AWS metadata service? We're going to focus a little bit on AWS right now, but really this metadata service is across the board. And one of the things, if you've ever heard of it, if you have any of your developers, it is a service that's a link local IP address on a virtual machine or EC2 instance in this case. It's 169.254 or 169.254. It is only routable through inside the virtual machine. And what it does is a lot of developers love using this to provide like critical information, OS information, IP address, subnets, if they have a public key, guest attributes. There's a lot of information you can put in on just what this virtual machine is accessing, as well as if the application needs that relevant information. A lot of times, a lot of orgs still have this on. It's on by default. It's really up to your org to figure out, do we really need this? And we're going to talk about the ways how you can really discover that. And really, once you're in, let's say, if you are in an EC2 instance, just hit a curl command, hit a curl space 169.254, 169.254 / security credentials. You can see if your EC2 instance is actually accessing an IAM role and is attached to that specific EC2. And I'll actually show a little bit about what that is and what happens with that. And now here, we know a little about what it is. Now, why do we care? As I mentioned, 90 to 95%. You heard that 90 to 95%. This was an anecdote I used to always tell everyone because anecdotally, whenever I'm on an IR, whenever I'm doing a proactive assessment, I always see an instance metadata service misconfiguration, which is the version 1. There's a version 2, and I'll discuss a little bit later on what version 2 means and how is that different and how is that a remediation for this. So Datadog recently did this about 6 months ago. They went through their 600 plus clients, and what they were able to see is 93% of all the EC2 instances that was hosted with that they were reviewing had IMDS v1 enabled, and about 95% of the organizations. So, as I mentioned, it is 19 out of 20 different clients. Anecdotally, that's something that I used to say 90+%. It's great that we have some data behind it, but I can actually echo this verbatim because I see this on a day-to-day. I see hundreds of clients a year through an IR or a proactive, and this is something that we see across the board. And one thing to note, this is not a vulnerability. It's a misconfiguration. So your vulnerability scanners are not going to catch this, right? This is where the change and shift from a vulnerability scanning solution, but for your outside, you want to have something like an attack surface management, where it may be able to not only catch the vulnerable apps that are out there and that are externally facing, but also what are the specific misconfigurations that can be abused by threat actors, right? Because this is not something your Nessus or whatever type of vulnerability scanner is going to catch as, hey, this needs to be remediated. And as I mentioned, IMDS v1 is on by default. This is, right now, there's no word from AWS, no announcement that I've seen where AWS is saying we're going to turn this off. So until that is the case, this is something that is still very relevant to everybody in here in terms of the current EC2 instances that are running in your environment and the future ones that are going to be coming out. This is something, as I mentioned, it's not new. This is why it's called old services and new tricks. This is not a new abuse, right? If you ever, I mean, I don't hear a lot of cloud talks that talk about Capital One anymore, but Capital One breach, if you remember cloud talks, anything 2 years ago, we used to have a drinking game. Every time they mentioned Capital One, we will just take a drink, right? And because you'll be out before the talk is over, because that is one of the biggest cloud breaches, one of the most prolific. Mandiant are the ones who actually did the investigation. I was actually part of the team. But the instance data metadata service, the IMDS, was the avenue of abuse that happened. So this is not something that is not new, but this happened in the summer of 2019. By November, AWS had already created IMDS v2. So they had already created a remediation for this. So, but the issue is it's still on by default IMDS v1, which is why this is still a rampant problem. With the metadata service, you can get a lot of credentials. There's something called a user data script. So whenever you're on an EC2 instance, think of a user data script if anybody in the old Windows days, logon scripts, right? Whenever you log on a computer, it runs, when I used to be an admin back in the day, we used to have logon script that, map drives or something like that. That's what a user data script is. And what we've seen, apart from just the IAM role being attached to an EC2 instance that can be abused, that we've seen threat actors utilize because it is in the instance metadata service, it could be easily taken by a curl command. People put passwords in their codes, right? Their PowerShell codes or their bash scripts. They have clear text passwords right there. So that's something also to look at. So this whole metadata service is really up to yourself and the organization to decide, is the juice really worth the squeeze? IAM role being as well as, problem is exacerbated once you have a vulnerable application that has an SSRF. And this specific talk is going to lead straight into what that is. So one of the big things, and the reason why I am here is, as I mentioned, this is kind of old, right? So 2019 is when this came out. This should have been fixed. Hey, why is this still a problem? Why is it six months ago, Datadog is saying 95% of clients and 93% of EC2s of their purview is still having this issue? And that's one big issue. Another big issue is why I'm here today is this is the first time we've seen, and I've talked with others in other cloud security communities. I'm part of Cloud Security Slack, and if you're part of that, definitely you want to get part of it. I've talked to a lot of folks, and this may have been the first time we've seen threat actors focus on one specific misconfiguration across an entire cloud platform site ranges. And specifically, this threat actor, we saw them spray and pray 2,100 different IPs across AWS. So the way they were reconning and the way they were doing this is at a mass scale. They were just trying to find anything and everything. And then from there, I'll kind of discuss how quickly they are able, once they're able to find something that's vulnerable with a IMDS version 1, how were they able to quickly pivot and get into the environment? And really, cloud is, a lot of people are scared about the cloud, which, there's ways to protect the cloud that even ways that you can't even do on-prem. But it's a really easy target for a lot of threat actors because the proliferation of resources, identity is everything, right? So the identity is a new perimeter to the cloud. That is the cache. Anytime somebody talks about about cloud, Identity is the new perimeter. So identity and credentials are so important. And the proliferation of resources really make cloud a very, very lucrative target. And one of the things we saw with this specific group, that they were targeting this specific vulnerable web application. And the reason why I'm not focusing too much on this web application, even though this was a crux of how they were able to kind of do about their business, is because there's this one CVE that's an SSRF. It was now remediated. It's going to be another SSRF CVE tomorrow and another one next week. So it's just because this is the only one, the real thing is trying to nip that whole thing in the bud and be able to remove the capability of, even if there is an SSRF that comes out, it's not going to affect your environment. And as I mentioned, really some critical information that can be obtained. And the issue is it's very limited in logging, right? Think about it. It is a link local address that happens internally at the EC2 instance. So in terms of logging, there's not a lot of logging that can happen or that a lot of organizations use. Or when you're looking at cloud, how many people here have like a CSPM where it kind of shows misconfigurations? Hey, like a Prisma or something like that. That'll show you the misconfigurations. Now, if it's being abused or not, and what are the logging is only happening at the actual EC2 instance. So you're having CloudTrail logs turned on, you're having all these things turned on. They'll only be able to show you that an attempt was made, but what exactly is happening at the EC2 level, specifically on the actual virtual machine, that's not being logged. So that's limited logging. So when we're going through our investigation, every investigation is a puzzle when you're trying to put this together. It's even a little bit harder when there's a limited amount of logging and how to kind of piece a puzzle. And I walk through how we were able to do that and able to really try to mirror the way the attack happened. And activities expand all industries and verticals. So this is not specific to NGOs and governments that a threat actor is doing. This threat actor is spraying and praying, as I mentioned. It's opportunistic. They are not going and doing deep research. They're trying to find any way they can find a vulnerable web app with the SSRF and IMDS v1, and then they're going to go about doing their business. And I don't want to only focus on AWS this entire talk, right? Instance metadata service is across all cloud platforms. Azure, Google Cloud. Azure does actually a really, really good job the way they've done it, because one of the things that they require, so during the header packets, they require metadata equals true to be a header. And then also they reject anything with an X-forwarded 4 in their packet. So what the X-forwarded 4 in a packet means is it's using a relay box or a proxy. That's where the packet is coming from. And we'll talk a little bit about how IMDS v1 doesn't do that. So it allows, let's say, an SSRF to be relaying their box and acting as if it's coming from internal. So that's one of the big things that is a big IMDS v1 versus v2. And Azure does an amazing job at that. Right away, they're actually very, close-knit to what exactly is happening. That's something they reject right away. But can you still abuse the metadata service? Yes, you can. If you use managed identities, Carl has done a great blog. If you get a chance, definitely look at this blog around managed identities. And Marius did this recently, just came out, where he kind of added on to Carl's great work and showed the way how you could really, really wreak havoc just through the metadata service. The big difference is you have to have access to the virtual machine before doing this. Versus what I'm going to be talking about is they're coming from the outside world and spraying and praying. So that's one of the big differences we are seeing is you have to have access to the virtual machine. And once you have access to a virtual machine, you can still abuse the instance metadata service a lot with different types of attacks. And same thing with Google Cloud. There's ways, I work for Google, so I would tell you there's different ways that you can abuse it, but it needs to be now within the virtual machine. One thing we require within Google is you need a metadata flavor with Google, similar to metadata header with Azure. The X-44s are rejected, but this wasn't always the case, right? The v.1 and the v beta 1, that was actually susceptible to something similar to this attack, but now that is nixed, and now It is only V1s that are available that, all instant metadata service requires a X44 to be rejected. Andrew Johnson from Atiga, great organization that does a lot of great cloud work. They recently came out, I think back in March, how you could still abuse the cloud metadata service, and working with Google and seeing how we can try to increase the verbosity of our logs to kind of give the organization as much information as possible. And ANCAT, this is from 2017. ANCAT's a great pen testing. If you ever have some cloud pen testing concerns, ANCAT's a great website. They actually had a deep dive on metadata abuse back in 2017. So as I mentioned, this is something that is not new to a lot of this cloud security community, but the way the threat actor approached this is something that's what we're concerned about. So wanted to kind of focus on one set of use cases and circumstances around a specific event, and one specific SSRF. So there was an SSRF vulnerability, a CVE that came out in February for a database management solution called Adminer. Some of you guys may use Adminer or kind of heard Adminer before, and it had an SSRF vulnerability early February. So the CVE comes out early February, and the proactive cybersecurity community came out with the POC, a proof of concept, within a few weeks. So we're talking about within a few weeks, we are seeing a POC on GitHub out there for people to use this SSRF to abuse it, and then it's just a matter of time. So we had this UNC 2903 come in, take that POC, and we have circumstantial evidence that this is the POC that they used, and then convert their POC into a auto recon tool to find any malicious Adminer tools that are out there in the wild. And from there, we saw once they were able to identify a malicious Adminer tool and they used this IMDS vulnerability, within 3 hours, they're inside an environment and wreaking havoc. So they are spraying and praying, but they are keeping an eye on if there's anything that is there, they're going and reconning. And once the recon happens, they're going and starting their mission right away. So then, if you fast forward, it took 5 months. So in June, we see that they created this automatic recon. They were able to obtain secret keys and secret access keys for the EC2, and that's what happens with the instance metadata service. We'll actually go through the demo of how we have kind of assumed the threat actor has created their environment and how they're able to create their local operational relay box and kind of fool that vulnerable adminer into getting credentials from the EC2 instance. And once they have that, it's just a matter of them logging in and going from there. And you'll see once they're in there, you're going to see your traditional kind of reconning within an AWS environment. They're reconning around S3 buckets. Then you'll see exfiltration. And the alerting, we're going to talk a little bit about what is happening with guard duty, what's the delay, and what exactly is happening there. So I want to get a little bit on the demo. So I'm going to walk through the demo that we have. So the demo is really focused on a few major things. One is the attacker local machine. The attacker local machine, it's going to be an operational relay box that then gets into a vulnerable application, an adminer application. And it's going to fool, because it has an SSR, it's going to fool the way the Python script is created. And I'll show you the Python script that we use. It is going to fool the adminer into thinking that it is coming from the inside, and you'll be able to obtain credentials of the EC2. We're talking about access keys, secret access keys of the actual box from the inside, as if you're from the inside. Then it's going to show, it's going to make a web request. If you have a little bit about web requests, with 302, and then after that, it's going to be followed by a 403. And so we're seeing all this, when we're looking at the investigation, we're seeing all this in terms of the forensics, and we're starting like, hey, why is this coming out like that? And that's how we're able to piece this together. And then once they're able to get that web request, then they're seeing the keys come in. And once the keys are there, then they're just a matter of them getting into the environment, reconning, getting the S3 buckets, and things like that. So step one of this demo that we put together is where the threat actor hosts a web server, their own local web server, as an operation relay box with a 301 redirect going to a vulnerable application, but specifically going and asking for the instance metadata service. 169.254, 169.254. So once they are able to find, so they're doing a recon and they're finding a vulnerable adminer account. So they're seeing a vulnerable adminer web app. They then point and redirect their specific tool to that adminer tool. So then that adminer, when you put in the IP address, it will spit out in the error message. And you'll see the error message you'll see with just secrets and access keys. Step 2, the threat actor navigates to a vulnerable adminer page. And this is around 4.0 to 4.79. That's kind of where this vulnerability kind of persisted. So it's a lot of versions they had that maintain that persistence. And they'll use this and they'll put in, let's say, Elasticsearch, and then just put in their IP of that specific EC2 instance. And it will basically be as if the account is, the request is coming from inside the EC2, which being linked local, it'll just spit out whatever it needs. The IP address and port of the box and whatever specific port number it's on. And then the victim server is going to be fooling and making the request, as I mentioned. And the server will follow up with the 301 redirect. So this is something when we're looking at the detections and how can you go through this, we're going to talk a little bit about the detections and what are specific things you're looking for. And then the victim server is going to spit out all these nice happy credentials around secrets and access keys. So what we're going to do here is we're putting in the Python script, showing the port number, attaching. So now the script is running. We're going to go and put in the Elasticsearch. So we're showing it going to Elasticsearch or MySQL, and then putting the IP address and port. And bam, you see that error message. This is asking as if it's coming from internal request. You'll see access keys. You see secret access keys to the entire thing. And I've been in a few presentations. I know not to mess with the demo gods, so that's why I'm recording this, because in conference, I don't know how many times I've been in conference presentations where the demo gods are not always on your side. But so as you saw how easy it was purely a local server, web server, being able to go to a vulnerable adminer on a client's machine, on a client external thing, and find that EC2 instance, which they're able to recon, and put in that IP address, and they'll spit out literally your credentials in order to get into their environment. And it was that easy. And this is where we saw this go against 2100. So they went and tried to find the recon across 2100 IPs. Now comes IMDS v2, right? So this was an IMDS v1. This is how they were able to do it. As I mentioned, v2 came out in November of 2019. And what's really happening here? It's a session-oriented protocol. It requires a put request to get a token, and with that token, you then could put in the get request to then be able to go and query the instance metadata service. It's a token that only expires however long you want it. You could create the session lifetime as long as you want, and it requires the unique header saying it needs a metadata service being true, but also the exported for automatically rejected. As I mentioned, that was a big key thing, because that's how that's how you can tell if the packet's coming from directly from a real request or coming in through a relay or proxy. And then we also have some new conditions around IAM policies, and I talk about how you can use IAM policies and SCPs, security control policies, to be able to block some of this and prevent this from happening. And they were able to create some new CloudWatch metrics to be able to see how much IMDS am I seeing in my environment. Is it V1, V2? You can take these same things and put that in your environment, and you'll be able to figure out what exactly is happening. So there are some native services that you can use to discover, right? So now we know what is IMDS v2. Let's first discover if we have it in our environment. There's native services, Security Hub, CloudWatch, as I mentioned, and the AWS config rule. That is all out there. After this, towards the end of this presentation, I'll actually link to a blog that we created where I have this specific CloudWatch, the config rules, the Terraform scripts, the exact CLI commands needed to do this discovery in your environment. But for the brevity of a presentation, I didn't want to put a bunch of code on here. But the code is there. We've already went through this in a detailed blog for everyone to be able to utilize. There's open source tools. So I am not somebody who's against using open source tools. I know there's great tools like Prisma and Cloudformity, and there's other great tools like Trend, Cloudformity, and other things that can find if it's a instance metadata service version 1 enabled, version 2 on a specific organization's EC2 instance. There's open source tools, Prowler being one of the most massive open source tool. If you haven't had a chance to look at it, Prowler is at such a cutting edge. It's an ex-AWS engineer turned, now he's doing Prowler full time. From my vantage point, the major kind of cloud community, the CSPMs that are out there, they're looking at Prowler because it's purely open source. There's a whole Prowler Discord group, if you ever wanted to get on, that I'm part of, that we create these new alerts and new checks all the time. And then I feel like the CSPMs are really getting the newer checks from them. Metabadger. Metabadger is created specifically to capture V1 and V2. You can actually use Metabadger to do the remediation. So once you see a V1 discovered, you can also do a remediation, make it a V2, or take it off. Cloud Mapper from Scott Piper, one of the goats in cloud security, as I like to call it. He created Cloud Mapper, which has been out for years, that focuses a lot on a lot of misconfiguration, but also talks about the version 1. And then there's plain CLI commands that you can use from AWS to be able to capture some of this. Now, detecting it, as I mentioned, so we've discovered it, but what are the detections? So when we're seeing some of this that's happening, it wasn't a lot, right? It's more of a piecemeal kind of investigation we had to put together because of just the nature of how the instance metadata service is. It's a link local. It is locally supposed to be querying local. But what we were able to kind of capture is what we saw the EC2 instance talk out on a 301 out of bounds. And that was like, hey, that's a little bit weird when we're looking at that. The 301 request that's going outbound, and then followed by a 403. And really, the 403, even if it's showing an error message, that wasn't really what we were caring too much about, because that already, after that, we saw when we coupled that with our VPC flow logs, we're seeing the outbound traffic from that EC2 going out, and how much data was being exfiltrated. And if you do have AWS, and you have an S3 bucket, make sure you have data access events or object level logging. This will allow your organizations to be able to have specific cases of what specific objects are being logged or are being exfiltrated, deleted. This is something I can tell you just from another anecdote that we have is a lot of organizations that just have server access logs on S3. We had this one case where we're going to do an investigation. We know that the threat actor was able to access an S3 bucket, but they didn't have object level logging. The S3 bucket had over 100,000 records. Because we didn't have object level logging, that then meant that we had no way to pinpoint of the 100,000, there's only 3,000 that was accessed. So unfortunately, with the way legal and when you're talking with legal and when you're doing the disclosures, because they weren't able to kind of figure that out, we actually had to do some mental gymnastics with billing data to find out billing data and what type of and how much that will correspond. But really, if they had object level logging in place, they then were able to figure out how many specific records were queried, how many records were exfiltrated, how many records were, let's say, if they were deleted like a ransomware scenario, they have that level of data. So if you do have an S3 bucket, ensure you have data access events or object level logging enabled. Of course, there's a lot of objects and a lot of logging that's going to happen. Focus really on your critical buckets, the ones that you really want to care about a lot. Make sure that is enabled. And as I mentioned, so GuardDuty came out with some alerting. So there's two types of alerts. There is the alerting that is happening from inside, which is coming from another different AWS account for this specific instance metadata use. And then there's alerting coming from external, which is from the outside, not on an AWS account, but purely from the outside trying to abuse the instance metadata service. But even in our own demo environment, so you're talking about demo data, it's very small dummy data, nothing that is like a production level. We still saw a lag. from the time we exfiltrated the data to when the alert came in. So, if you're really focusing so much on just, the whole point is you don't want to put all your eggs in the alert basket. Because by the time you might get an alert, they're already gone with your data. So this is where the preventative techniques come into play. And really, what you want to do, as I mentioned, is talk with your DevOps, talk with your organization to figure out, do we need IMDS at all? Do we need to have this linked local address that is could be abused in the future, even externally, but also internally still can be abused? And that's something you can literally turn off completely. Not every EC2 instance, not every virtual machine that is on the cloud needs to have the IMDS enabled, right? It's really case by case basis, and I talk about this in the blog when I wrote it on how you can remove the whole capability. And if IMDS is needed, definitely want to enforce a V2. I've done a lot of remediation exercises during an IR and post during like proactive. And I really haven't seen a lot of organizations falter, right? There's always going to be a little bit of consternation around, if I were to enable this, then what type of will my applications not work now to use a session-based protocol? So I haven't came across this. I don't want to say that's never going to happen, but talk with the DevOps folks when they are ensuring that if they need it, let's go to V2, let's test it, and then also being able to kind of detect and remediate all instances. And now let's go to the prevention, because that's really the key. How can we prevent this from happening, right? So we discovered it, we detected it, we're remediating it. Now how can we prevent it? There's the SCP policies that says any API call that doesn't use the IMDS version 1, we're going to take that away. We're going to ensure that all of it's going to happen with version 2. There's a Terraform and CloudFormation templates that are created. So anytime you create an EC2 instance, it starts with a version 2. And all that is part of the blog that I mentioned a little bit. And then there's IAM policies. There's the local IAM policy within the AWS account that says any EC2 instance that gets created, if it gets created with version 1, it's not going to be spun up. You can create it only with version 2. And these are all ways that you can prevent this from ever happening, right? So that's the whole point. I do love IRs. Don't get me wrong. I love it. It's riveting. It's fun stuff. But if we could prevent this from happening, that's what I really care about. And that's where I really hope all the organizations can kind of take that lead. Some additional prevention. So you can ensure your as I mentioned, the user data script being like a logon script. Ensure if you do have user data scripts, tell your DevOps, are we using user data scripts on our EC2 instances? You could use something like a Scout Suite. Scout Suite is another open source tool by NCC Group. They are able to read the EC2 scripts, and also you can see if there's any credentials. Prowler has the same feature. Limit the number of HTTP hops. It can go from 1 to 60, right? And if you don't have a limit, you could say having only one HTTP hop. So if it comes from a relay, it'll have 2 hops, right? It's not coming from directly from that one box. So if you put it to just 1 hop, it'll block a lot of these types of attacks. And these are all kind of substitute remediations, just in case if they can't go to IMDS V1, V2, then let's focus on how we can create more compensating controls to try to block this from happening. You can limit the API calls used to IMDS V2 only, as I mentioned, through IAM policies, and you can also modify who can access the instance metadata service. So I also put that in there, how you can say, with IP tables saying, only Bob, the user Bob, can only access 169.254, 169.254. And he is the only one who can route that. And no one else or if they are coming into this EC2 from the outside or coming in using a different username, they won't be able to see it. So now we're going to do another demo, all right? And this demo, what we're going to do, the only change we've done is we enabled IMDS V2. So what you're going to see, we're going to go through the entire thing again. So putting this through and putting that Python script, the same script we put in before, same box. But what's going to happen is, in the background, we did some magic and we put in version 2. So put in the same IP address, Elasticsearch, all that, and then you're going to see an error message. That error message essentially says, hey, you're not coming from the outside, so we're going to error out your request because you're trying to act like you're coming. Remember, this is still the same vulnerable adminer. We have not updated the adminer update for these web app. But because of the IMDS v2 being enabled, it allows us to, even with a vulnerable application, block this type of attack. As I mentioned, here's this a blog that we did. It's a detailed blog where we talk not only about the investigation. I dedicated about 10 pages of just detection, discovery, remediation, and prevention. So if you have, like I said, if you have AWS, if you have instant metadata service, definitely you want to review this because this is something that is happening everywhere, in almost every environment, and we want to be able to get ahead of it as much as I can. And that concludes my talk. Is there any questions? Awesome. As I mentioned, my business cards are here. If you're looking for a job or looking for a change, definitely reach out to me. I'll be more than happy. Hit me up on Twitter, LinkedIn. I'll be more than happy to route you to the right folks. Thank you very much.